Okay, we're going to talk about the NDF reading. If you've read through it by now, I'm guessing you might have some questions. So this short video thing here is meant to help you work through some of the questions you might have had before we get to our discussion, which we'll try to do this coming week. So the first article, NDF digestibility, are you confused? Some of the main points we need to think about is that when we're thinking about measurements in a lab versus measurements in a cow, the cow has two things that a lab will not. One is that there'll be passage rate. The NDF can potentially leave the rumen. When the NDF is in a lab situation, it cannot leave its circumstances. But a cow can have stuff move to the lower track. And when that happens, will influence how much time it spends in the rumen and therefore how much is digested. There also can be issues of circumstances. You're going to have in a lab something that's very well buffered, never have a low pH. You may have slug feeding ruminal acidosis for short periods of time, which are all going to hinder NDF digestibility. So there may be specific circumstances and variability in a cow that you won't find in a lab. Lab you can think of as more or less ideal conditions to get that digestibility. Our job is to feed our cows in such a way that we can get that measurement in our cows as well. As we've mentioned, you've got NDF, digestible and indigestible. So when we say digestible, we're talking about rumen fermentation by microbes, and that's something that at least for me, it was confusing when they're talking. Well, you're talking digestible. Is that so? Most nutritionists talk about NDF digestibility. What they really mean is the fermentability by microbes. So make sure you get that transition, that connection in your head. When we talk about our NDF, we're talking about a lag phase. There's a certain amount of time in the rumen where nothing happens. You've got the fast fiber pool, the slow fiber pool, and then the indigestible portion of the NDF. And as we mentioned in our rumen discussion, turnover is passage and digestion. So turnover is disappearing from the rumen. There are two ways that can happen. The microbes can rip it apart, turn it into protein, turn it into VFAs, or it can pass to the abomasum, small intestine, lower tract. So turnover is about disappearance. If we look at some of the charts and figures in this diagram, it'll help us sort of understand what we're dealing with. So you've got 2005 New York corn, Cumberland Valley. They put out averages every year, so everybody gets a feel for what's going on. Acid detergent fiber is certainly lower than our neutral detergent fiber on our corn. The difference is hemicellulose between the two. Lignin fairly low, moving through. NDF, usually we have big enough particle size that most of the NDF that occurs in our forages will stimulate chewing. The stuff that occurs probably on the seed coats is not going to generate as much, and that might be 10% in our corn silage, a very small amount of the overall total. We can talk about digestibility all the way down to here. And then we talk about undigestible. We have 120 hours, 5 days, 240 hours, 10 days. And they notice that there's a little bit difference here. This is a little bit higher than the example we gave you. But we say about a quarter of our NDF is not available, maybe a quarter to a third. And then we think about the NDF in vivo or in vitro. So if we look at what's digested, so in the first 12 hours, we lose, in this case, on average, we lose 30. We lose 24 hours, we lose 50%. And that's a fairly typical number for NDF digestibility. 57, 58%, 64 at 48 hours. The particle is going to leave the rumen somewhere in here. So we're going to look at 50 to 60% of that NDF is going to become available to the animal in the rumen. The lower this is down here, the more we have in a fast pool, and the more we're going to get up here in the front side of things. The more we're going to extract more in that first 24 to 30 hours. Looking at that stuff graphically, we can see that a number of variables come together to give us that shape of the curve. So we may have a lag phase. This looks, at least from my perspective, a little bit longer, but Mary Beth Hall, Dr. Hall is one of the best in the world, so we have to go with her diagram, at least in some way, shape, or form. You've got the percent digested, so we're talking about 0 digested at the top here, 100%, and then we've got our hours going out here. So, I mean, this looks like 24, this is like 12 hours. That seems like it's a little bit long for a lag phase. I usually think about 2 to 3, so maybe it's going to come down a little bit faster. You're going to get into that fast fiber area, and then you go to the low fiber area, and then you're going to have, depending on the feed stuff, you're going to have an indigestible level here or maybe up here. And we may have different rates of getting there. So this dotted line here, dashed line here, is a faster digesting digestible fiber than our dotted one here. Takes a little bit longer to get started, but they're going to end up in the same place there. You've got potentially digestible feed, and then indigestible, the UNDF, DNDF, and then depending on how long things stay, we can get more or less ruminal digestion, ruminal fermentation, 24, 30, 48. Typically, we're in this range of our feed particles staying in the rumen. Moving on to the next article, talks about forage digestibility beyond just a simple NDF. It's talking about quantitating your DNDF and your UNDF. So dividing it digested DNDF or undigested or UNDF. And we're going to need measurements on all these time periods to start to do the math, the calculus that's going to allow us to create the different pool sizes, the different rates going through. And we're going to think about the extent of digestibility, how much of that feed stuff NDF is digested, and then the rate at which that happens. And that'll be called sometimes a KD. So K is usually for rate, and then this is a rate of D, rate of digestion. So, and it either can be a proportion per hour, which is KD, or we can divide it or multiply it by 100 and get a percent number. When we think about indigestible NDF, that's been a school of thought that's come about in the last 10 years. We focused on the digestible NDF. The UNDF, kind of looking at the mirror image, gives us some thought about other characteristics of the feed stuff. And our undigestible NDF usually helps us predict our rate of digestion. If we know what the bottom is, our potentially digestible pool, we can figure out the rates with that. So we need this number here, the undigestible portion, to figure that out. It's pretty well related to the organic matter digestibility. The more undigestible NDF we have, the more likely that feed stuff is going to be unavailable, more likely it's going to be older, tougher, more lignified as you go through. And then it's also a pretty good predictor of fill. The more UNDF we have, the more likely it is not to be digested. It's going to stick around in the rumen longer, slower rates of digestion. It's going to fill up the rumen and stay there longer. So there are some schools of thought where you can say, okay, I can feed so much UNDF a day, and that's kind of my limit for what the animal will take in. So if we look at figure 2 and table 1 from that article, we have a figure 2 digestion rates. This is comparing our grass and legumes. So we've got the in vitro digestibility, the fraction of that. So this would be equal to 80%, 70%, 60% is digested. And we have two lines here that we've kind of lost the color here, but we know that this line here is our alfalfa. Alfalfa has a higher UNDF than our grass, which is this upper line. But we know that alfalfa digests faster, but not as much. Grass digests slower, but it has a lower UNDF than alfalfa. And this may be the reason people have used alfalfa over the years in our lactating cows. We get more energy, more protein from our alfalfa faster than we do our grasses. Our grasses tend to be more filling. We tend to show day, we want to have the grass in there to fill them up, to fill them out. That slows things down. We've got slower rates. So, but ultimately, it's slower rate of digestion, so more filling. So, but there's some advantages to those over time, maybe feeding that a little bit longer. So we go down here in vitro, NDFD, NDF digestion as a percent of NDF for various feedstuffs. So we got 24 and 30 for each of these. There are schools of thought. Well, 24 is the number you want to use. 30 is the school you use. People go back and forth in this class. It really doesn't matter so much because we're going to be doing that math. So you've got, again, Cumberland Valley doing a whole lot of determinations on those, mean range. So we assume more or less rightly that our 24 hours is going to be lower than our 30 hours. And that's one of those two is probably our typical residence time of NDF. NDF kind of is the rate limiting thing there. So it pretty much is near 24 hours for how long it stays in the rumen. If it stayed longer, it's going to fill up and back up into the rumen. If it went faster, the animal's going to eat more, consume more, so you're going to get more intake as you go through. So digestibility for that there, we've got a corn silage 40 and 52, legume silage 45 and 51, 51 and 60. So you're going to get more digestibility of your grass silages. You're just not going to get them as fast. And then our corn silage is kind of a modified grass, so it appears like it's going to fall in between those two. Those are the numbers we're working with, and that's what we're going to use as we balance going forward. So what we need to think about is, okay, how much of our feed stuff is probably going to be digestible, and that's what our ration balancing programs do. They predict how much NDF, how many pounds NDF are going to be digested, how many pounds of each of the other things, and we call that the pool size. How big is that pool, and then how fast or how digestible is that pool? So we have in our legumes, we have a smaller pool. We have less digesting here than we do here in the grass, but the rate at which that's available is much faster. So a couple other tables from there. We compare the conventional to the BMR, same average dry matter, lignin, because it's BMR, it's going to definitely be lower. We're looking at about 2/3, 50%, somewhere there, less lignin. NDF, reasonably similar, but we've got a 10-point range here in 24-hour digestibility and almost a third more digestion per hour of that, and that's where the advantage of BMR is. We're turning that NDF over faster in the rumen, the digestible. Passage is probably similar, but we're extracting more in a faster period for our cows. And some different expected measurements. Again, this is Ward is Cumberland Valley. Recently measured values, key forage groups. So we've got NDID as a percent of NDF. So this also could be UNDF. So the higher the lignin, usually the greater the percentage of UNDF. So you got your threes here. Depending on what grass tends to have more NDF for the same dry matter than our palages. So we're going to have, since we got more NDF, we may have a higher lignin. The lignin to ratio there is more or less constant, but you've got less total NDF to start with. So you're going to be restricting that. You've got more there. So the ratio of what's left versus more total NDF, you've got a certain amount there that's going to be taken care of. And then we got a TMR, more or less set. Maybe not the best explanation on table 3. Our article, high quality or the right quality. You got Mary Beth Hall, again, working on this paper, I believe. NDF, we needed to get digested for BFA and protein, and form maintains the healthy rumen. So 2 purposes of NDF: to generate it for the things the cow needs, and we need it in that physical form to keep the rumen healthy. That form is determined by particle size mostly, digestibility. The longer it's in the rumen, the more you're going to stimulate rumination, clean that wall. The longer the particles, the longer they stay in the rumen. Hydration and fragility also affect it. If they're not hydrated, they don't get ripped apart. That's part of the lag phase. And fragility, how strong are they as particles? The tougher they are, the more they're going to stay in a form that's going to keep the rumen healthy. We can measure all these things in the laboratory, but really what counts is the cow. And we judge the cow, judge how well the cow does by cud chewing. So that's why we want to go in and observe our animals. And then we got our manure in some way, shape, or form. So we'll take a look. So if we've got minimum NDF in the ration, we need a higher percentage of that as forage. We want to make sure that we've got minimum forage NDF. We need more forage NDF as we go down. We need to make sure we get that particle size on our lower NDF rations. As we go up higher, we may not need as much NDF because the other types of NDF will help stimulate chewing, will dilute things out. So with lower NDF, we have to make sure more of it's coming from forage, so minimum of 19% forage in the diet. We can go down to lower percents of forage in the diet if we've got higher amounts of NDF in the diet coming from other sources. And then we have the maximum NDF NFC percent that we can put in there, or we balance things out. I think there's a number missing in there somewhere. I think that's supposed to be a 4.0, would be my guess. If you look at the minimum NDF ration and the maximum here, and it's an odd relationship of everything kind of adding up to set near 70%. Look at the particle size here. We've talked about the sieving. If the rumen is working well, the forage is being digested, and it's being chewed and broken down, we should get a good breakdown of particle size. Um, Things are fine and stuff. If the rumen is not working well, the cow will start to push feed out before it's fully chewed, it's fully digested. It's going to try something there. So we've got bigger particle size, less ruminal retention, poor digestion. We need things to stay in the rumen to get chewed, to be broken down by both the teeth of the cow and the microbial digestion activity. Um, if things are not being fermented the way they should, the cow's going to be hungrier. She's going to force feed in. That feed is going to push out these big particles, and things are not going to be as efficient. You're not going to get the digestibility from the uh, uh, rumen, so you're not going to extract what you could from the diet. You're going to lower your efficiencies. Your feed efficiency is going to go down. So let's double check the caption here. Two samples of rinse manure cows provided the same TMR. This was a good looking cow pie. The one is bubbly diarrhea. The large particles represent feed that escaped the rumen before it was sufficiently ruminated and digested. So this is what we're looking for. This indicates a problem. And there are lots of reasons besides diarrhea that this may not happen. Acidosis, a dead rumen, some sort of vomitoxin anti-quality factors that may mess things up and force things out before they're fully taken care of. So figure 2 here, NDF content of forages, make a rough estimate of how much of a given forage can be included. So if straw is 80%, we can maximally include 26% of that in the diet. And this goes back to the cow has a certain amount of NDF it can eat in a day. If we have something that's mostly NDF, we're going to feed less of it in the day. So as the percentages go down here, we can include more of that feed stuff in there and still allow we're doing forage NDF at 21%. So NDF in the dry matter that comes from forage equals 21%, starting at 28% NDF in the diet. And then as we move to more forage NDF, we can reduce the amount of volume that or proportion that takes up in the diet as we get to lower NDFs, forage NDF. So corn silage typical 40-45. We can include more of it in the diet and still not overload or overfill that rumen. Feed too much straw, she's going to fill up, but she's not going to be extracting the energy she needs to produce milk. So this one, I'm not sure you can see your lines. I drew them in here with the yellow pieces. Talks about the forage fiber digestibility variation within a feed stuff. So 30-hour digestibility. Grass, we can have a third, we can have almost half, we can have 2/3 of that forage NDF might be digested. Corn silage, you're going to have a narrower range, but almost 40%, a little less than half, a little over half might be digested. So bringing to the point, things are highly variable. They depend a lot on the crop, the maturity, the growing conditions, and that fiber digestibility determines the available or is correlated to the available nutrients in the feed. Moving on to Feed More Forage by Larry Chase, and certainly in my time, most herds have gone to higher forage diets on the assumption that Forages are cheaper than grains. Depends on the economics. There have been times in my lifetime it was cheaper to go with grain. When you had $2 a bushel corn, it was probably cheaper to go with grain than it was forage. But again, it depends on how your system is set up and what it costs you to produce each ton moving through. But generally, if we put more forages in the diet, our animals do better. And this is a function of, certainly in the Northeast, we've gotten better and better at putting up forage at the right time, harvesting at the optimum time. The BMR corn and now the alfalfa has made the forage more digestible so we can feed more of it in a day and still get the production out of the animals. If we move into higher forage levels in the diet, so 60, 65 is fairly common. 20 years ago, it used to be about 50-50. And again, that's not the best way to characterize a diet, but it is a way to think about the diets. What we really care about is the level of NDF in the diet. So Dr. Chase talks about all the benefits associated with the forage levels, less acidosis and better rumen health, better rumination, more extraction of things in the diet. These are all going to lead to the list of benefits that he had there, ending up with the potentially improved opportunity for profitability. To make that work, he talked about 8 different keys, and you can read those for yourself. We talked about the mindset. We got to think about, okay, this is what we're going to do, and we got to keep doing it, and we got to focus on quality forages that allow this to get done. We need to be consistent in the way we do things. We make sure we have enough forage to feed 10, 15, 20% more forage in a given day. Make sure we have the inventory, make sure we have the best stuff allocated to our highest producers. BMR really isn't really necessary for our dry cows or our heifers, but it makes a huge difference with our lactating cows. And that's one of the reasons we're getting the production out of these animals that we are, um, even without BST. We need to stay on top of things, make sure we have things now analyzed. We can't go certainly from year to year without doing that. We want to do a couple of samples up front, depending on our silo type and shape, and keep on top of things. We're going to formulate for the quality of that NDF, the undegraded or undigested digested NDF. Make sure we have a ration balancing program that occurs for that. We got to make sure that we feed right, make sure our bunks are always full, and make sure we don't overdo it with our mixers. We don't pulverize our BMR corn by over mixing. So a lot of things have to happen.